Yeah, we have done that compressible fluid. We have started with compressible fluid, and we have found out relation how the pressure can be found out. If one pressure is known, how the other pressure can be found out with the relation. For that was for isothermal fluid, right? Those fluid which are under isothermal conditions, so they can be predicted the pressure drop, or if one pressure is known, the other pressure can be also found out, right? So we said that we will do some problem so that the understanding of the use of the equation can be more effective, right? So let us look into one, like methane is being pumped through a 1 meter ID pipeline for a distance of 1 10 to the power 5 meter at a rate of 2 kg moles per second. The equivalent roughness of the pipe is 4.6 10 to the minus 5 meter. It is assumed that the line is isothermal at 290 Kelvin. The viscosity of methane is 1.05 10 to the minus 5 Pascal second. The pressure at the discharge end of the line is 200 into 10 to the 3 Pascal absolute. Calculate the pressure P1 at the inlet. Right? So I repeat, methane is being pumped through a 1 meter ID pipeline for a distance of 1 10 to the 5 meter at a rate of 2 kg moles per second. The equivalent roughness of the pipe is 4.6 10 to the power minus 5. So equivalent roughness is given here. That means epsilon is given. Relative roughness you have to find out. And from there the frictional factor value from the Moody's chart, right? So 4.6 into minus 5 meter. It is assumed that the line is isothermal at 290 Kelvin. The viscosity of methane is 1.05 10 to the minus 5 Pascal second. The pressure at the discharge end of the line is 200 10 to the 3 Pascal absolute. Calculate the pressure P1 at the inlet, right? So if we remember the relation of P1, right, pressure, that we said P1 square minus P2 square, right, this is equals to 2 G square RT by M, right, into ln of P1 over P2, right, plus 4 F G square RT delta L over dm. This was the relation for the pressure at isothermal condition, right? Our given things, let us write down. Given G is equals to 2.0 kg mole per second, right? 2.0 kg mole per second. And this was for the gas methane. Methane is CH4. So CH4 means 12 plus 4 is equals to 16. Molecular weight is 16. Right? So this 16 molecular weight means 16 kg mole per kg. Right? So, if we multiply this with 16, then it becomes 2 kgmole per second, right? So, into 16 is, this is kg per kgmole, sorry, the reverse, kg per kgmole, 16 kg per kgmole. So, that is the molecular weight. So, 16 in kg per kgmole, right, into area, right, into 1 upon this area or divided by area, that is pi d square by 4 meter square, right, pi d square by 4 meter square. This means this kgmole goes out, kg per second per meter square, right, that is nothing but mass flux, right. So, if we substitute the values, then it becomes 2 into 16 divided by pi into d square, given d is equals to 1.0 meter id. So, 1, right, and other than d we need here nothing. So, 2 into 16 into 4, this 4 goes up, pi, this square is 1 square, right. So, pi you can take as 3.14, right. Then if we put it into the calculator, then we can say that 2 into 16 into 4 is equals to this divided by pi. Pi, if it is not there, then let us take 3.14, right, 3.14 into 1. So, that means it is 40.76, right, 40.76, 7, say so much of kg per meter square per second, that is the mass velocity or mass flux. This g is rho into v, mass velocity, or this is called mass flux, kg per meter square second, right. So, once we know that kg per meter square second, then we can now say that NRE is equals to 4.6 into d, rather d v average to rho by mu, right. D is given 1, v average we assume 40.7, right, and rho is given as the viscosity this much, the absolute for distance rato this much, so roughness this much, viscosity of methane is this much, right. Okay, then we have to find out what is the 200 line, 10 to the minus 3 minus 5 Pascal, roughness is so much, methane is being pumped at a distance 1 meter, 2 kg/meter, right. Oh, so G, rather rho V we have already found out, right. Rho V we have already found out. So, this is rho V is G. So, G is 40.7. So, 1 into 40.7, this divided by mu, mu was 1.05 into 10 to the power minus 5. So, if we again look into that calculation. So we can see that 1 into 40.77 is equals to this much divided by 1.05 divided by 10 to the power minus 5, right? It is 3876190.47, right? So much the value of Reynolds number. So here we see 3876190.47, but there it is coming 3880571.4. The reason being we have taken 40.7 as the G value and it is taken in this problem as 40.746, right? So that is where the change. Now epsilon by D, right? This value epsilon is given as 4.6 into 10 to the power minus 5 and the value of D is 1. So this is 4.6 10 to the power minus 5. So corresponding to NRE is equals to this and epsilon by D equal to this. If we see the Moody's plot, NRE versus F for epsilon by D equals to this 1.6 etc. we get a value of F, right? And this value of F we assume it now to be seen as 0.0028, right? So if we assume that the value of F is 0.0028, then we can then substitute F, this is equals to F. So we can substitute in this 2G square RT by M of ln P1 by P2. So first find out this constant value. So 2G square 2 into 40.7 square into R, right, 8.314 into 10 to the power 3, right, into R into T. T is 290 given 290 Kelvin, right, divided by molecular weight is 10 CH4 16, right. So if we find out this value, this becomes equal to, let us look into how much this value comes in. That 2 into 4, 40.7 square, 40.7 square into 2 into 290, this divided by 16 is equals to 60047, 60047.7625, right. This is coming to be equals to 1, 2, 3, 4, 5. Oh. No, we missed out this. So that is what the problem. When you do this, you miss some or other. 40.7 square, right, into 2 is equal to so much into 8.314. Oh, 80, okay, 80.314 into 100, not into 3, into 100 into 290 this is so much divided by 16 is equals to 48, not this 60. We missed out this term. So it is 48226759.9.7425 means 1, 2, 3, 4, 5, 6, 7, 8 is equals to 4.8 10 to the power 8. Right? 4.8 10 to the power 8. Right? That's why it is 4.8 and 5.03. The difference again because 40.7 and 40.745 or 754. Okay. Now once we know this and the other term, that is 4f delta L g square RT divided by dm, the values are 4 into 0.0028 into delta L, length is given as 1 10 to the 5 most likely 1 10 to the 5, right? Yeah, 1 10 to the 5 meter. It is 1 into 10 to the 5 meter into g square 40.7 square into r 8314, let us take this way, into 290 t divided by diameter is taken 1 and molecular weight is 16. So this comes into as 4 into 0.0028 into 1 into 10 to the power 5 into 40.7 square is equal to so much into 8314 into 8314 into 290 is equal to so much divided by 16, right? So this is equals to 279.2795727745558 means 1 2 3 4 5 6 7 8 9 10 11, that is 2.8 into 10 to the power 11, 1 2 3 4 5 6 7 8 9 10 11, right? So if that be true, 2.7 10 to the power 11, right, 2.8 10 to the power 11, then this term is much bigger than this term, right, 4.8 10 to the power 8. So what we can do, that we can then neglect the first term, that is we can neglect this term, this P1 by P2 ln of this. If we neglect that, then we can write P1 square minus P2 square, that is roughly equal to, right, 4f delta L g square RT over dm, right? So if that is we have found out to be equals to 2.8 10 to the power 11, right? One is given, the value of output 200 10 to the power 3 P2, that means given is P2 is equals to 200 10 to the power 3 Pascal, right? 200 10 to the power 3 Pascal, that is 200 kilopascal. So if we substitute this in this, we can write P1 square is equals to 200 into 10 to the power 3 square, right? Square. This is equals to, or rather this is equals to this plus 2.8 10 to the power 11, right? So on simplification, this gives, let us see what it gives. This gives on simplification that 200 into 10 to the power 3 right. This is square, so square of it, right, plus 2.8 into 10 to the power 11, right. So this becomes equals to this 32 1 2, how many zeros? 1 2 3 4 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6 7 8 9 10, that means 3.2 into 10 to the power 11, right. So therefore we can write that P1 is equals to under root of 3.2 10 to the power 11, and that comes to equals to square root of this square root, okay, 5 6, this is equals to 565,685.4, right. So that means this is equals to 565.685 kilopascal, right. So let us look into how much it was obtained. Yes, 565.865 or 866 kilopascal. So this is one way of doing that, right. So another way of course can be that whenever you are making it, that time you have to be sure that this P1 we have not taken into P1 by P2, right. So it may so happen that P1 by P2 may be required. For example, another quick one, air at 290 Kelvin and 300 kilopascal enters a pipe and is flowing in isothermal compressible flow. In the pipe having an ID of 0.1 meter, the length of the pipe is 50 meter. The mass velocity at the entrance of the pipe is 1700 kg per meter square second, and assuming molecular weight of air to be 29, the friction factor to be 0.004, and the viscosity of air to be 2.2 into 10 to the minus 5 Pascal second, calculate the pressure at the exit. So inlet pressure is given 300 kilopascal, exit pressure we have to find out, right. So we start with again from what are given are epsilon by d. No, epsilon by d is not required. So F is given directly 0.004. Then D is given is equals to 0.1. Then T is given to be 290. P1 is given to be 300 into 10 to the power 3 Pascal, right? 300 10 to the power 3 Pascal, and mass velocity G is given 170 kg per meter square second, right? And molecular weight of the gas or air to be 29, viscosity of air to be 2 10 to the power minus 5 Pascal second. So from there, if we find out that 2 G square RT by M, that is equals to 2 into G here is 170, right, square, R is 8314 into RT 290 by M, molecular weight is 29. If we look at quickly what is the value coming, then we see this is 2 into 170 into 170 square, okay, into 8314 into 290 into 290 is equal to this divided by 29, right? So that becomes equals to 4805492 1 2 3 4 5 6 7 8 9 is equals to 4.8 10 to the power 9, right? That was one. The other one which we found out, 4F delta L G square RT by dm. So in this case 4 F is 0.004 delta L, right? It was perhaps given that ID so much 50 meter. The length of pipe is 50 meter. L is 50 meter, right? So we can write this 0.005 into 50 into G is given where is 170, right? Square, R is 8314 into 290 divided by D, diameter is 0.1 into M, molecular weight is 29, right? So if we look at this value quickly, this is coming 4 into 0.004 into 50, right, into 170 square, right, 170 square into 8314 into 290 is equal to so much divided by 0.1 divided by 29. This is equals to so much is equal to 1922196830. That is 1 2 3 4 5 6 7 8 9 10 is equals to 1.92 10 to the power 10. So one is 10 to the 9, another is 10 to the power 10. So in this case, then what we need, the inlet is known, right? Outlet has to be found out, right? So from the equation which we had shown earlier, that this equation P1 is known, P2 has to be found out, and this value we have found out, First assume a value of P1 and make this ln of P1 because these two values are not very far away. So we cannot neglect. So take one P1 assumption, find out what is the value of P1 real. So assumed and real when they are very close and to the first or second decimal it is accurate. Till that time we can say that this has been up to the first or second decimal according to your liking is true or is done, or it is the value real value which is up to first decimal or second decimal. Okay, this way by trial and error you have to find out the pressure. Okay, thank you.